Question number 61. We've seen this kind of question before. Just going to test you again to make sure you understand this one. The radius of circle R is 20 feet. Segment RT is 28 feet and segment ST is 21 feet. Is line TS tangent to circle R? Remember, we know it's tangent if we know that this angle right here is 90 degrees. So prove whether it is or is not and write your final answer and proof as a complete sentence. Alright, so let's go ahead and label our diagram. The radius is 20 feet. The length of RT is 28 feet. The length of ST is 21 feet. And we're going to treat this side as our hypotenuse, because if this were a right triangle, that would be the side that doesn't touch the right angle. Let's go ahead and set up our equations. Pythagorean theorem used to prove whether it is or is not a right triangle. A squared, I'm going to use this side right here, the radius, as A, plus B squared, that's 21 squared, equals C squared. If this is true, we've got a tangent line. 20 squared is 400. 21 squared is 441. 28 squared is 784. Let's add like terms over here. We've got 841, and that clearly does not equal 784. And based on that, we can know that line TS is not tangent. It must be touching the circle R at more than one place. So even though radius RS is touching the tangent line, there must be another point that TS is touching the circle, because otherwise that would be a right angle. So we're going to write this as a sentence, and here's what we'll write. Since angle RST is not a right angle, then we know that line TS is not tangent to circle R. We proved this. We've got our conclusion. Here's our evidence. Sorry, our conclusion is line TS is not tangent to circle R. Our evidence is angle RST is not a right angle, and we know that because we've used Pythagorean theorem to show that this triangle RST is not a right triangle. Alright, last question. Number 62. This look familiar to you from an APT we did. A satellite orbiting Venus calculates that the shortest distance to Venus is 10,300 kilometers. I'm going to go ahead and label that right now. So I'm going to draw a line segment to Venus. Let's notice that the shortest distance is to the planet's surface, and that means this segment right here is 10,300 kilometers. And the distance to a point tangent to Venus is 15,191 kilometers. Let's go ahead and draw that segment. I'll just go ahead and go past the planet here. Let's make that green as well. And let's pick a point here that we see it's touching the circle. And I'm going to go ahead, let's just go ahead and finish this triangle. Oops. How about if we draw a straight line? So we'll complete our triangle there. Okay. Use this information to calculate the approximate radius of Venus. Write your final answer in a complete sentence. Include an explanation of how you calculated the radius. Alright, well, let's label our, we got to label this side right here, which is 15,191 kilometers. And remember, class, this 10,300 only goes this red dot. That means we have the radius left here, and this leg of our triangle is the radius here. If this line is tangent to the circle, that means this is our right angle. And that means this is our hypotenuse. And I had some students look at this triangle and they didn't label the hypotenuse, and they just made the assumption that the longest side is the hypotenuse. But this is not the longest side. We haven't added r into this side yet. So think of the hypotenuse as the side of the triangle that does not touch the right angle. Alright, let's do our calculations here. See if I can get this right the first time. Okay, so we're going to take a leg of our triangle, which is this top one right here. 15,191 squared plus, there's our other leg, radius squared is equal to, we don't know the length of this side yet. Our hypotenuse is going to be r plus 10,300, and that whole thing is squared. Alright, we know that when you square a binomial, it just means write it twice. So this is equivalent to r plus 10,300 times r plus 10,300. I'm going to move over a little bit to the left on this class so that I have enough room. So let's do our next step. We've got 15,191 squared plus r squared. Let's distribute. The r gets distributed to the second binomial. And then the positive 10,300 also gets distributed to the second binomial. Okay, let's keep on writing here. Be careful about writing your numbers. Don't make the mistake I did on the video where I copied the number down wrong. Let's distribute the r into the first binomial. R times r is r squared. R times 10,300 is 10,300r. Let's fix that. Okay, 10,300 times r is also 10,300r. And these two numbers are the same. We're just going to square it rather than multiply it out and get some big number. That's 10,300 squared. Okay, we've got a like term that we can combine, and we've got a common term on both sides of the equal sign as r squared. We can get rid of that. Subtract r squared from both sides is going to cancel it. So now we got 15,191 squared equals 10,300r plus 10,300r is 20,600r plus 10,300 squared. Alright, now we're going to get rid of the 10,300 squared. We're going to move it from this side to this side so we can start getting r by itself. We're going to subtract 10,300 squared from both sides. Now, I had some students a couple days ago actually think to themselves, you know what? I'm just going to take 15,191, subtract 10,300, and then square it. But class, that does not work mathematically. You can check that out real quick by just doing a simple question. What if I had 3 squared and I was going to subtract 2 squared? Well, that's 9 minus 4, which is equal to 5. But if I followed that rule, then I would say, oh, I could also just subtract 3 minus 2, and then square it. Well, 3 minus 2 is 1. 1 squared is just 1. You see, this does not come out to be the correct answer. So even though that looks like a shortcut, it's one you don't want to use because you're going to end up with the wrong answer. We're going to have to square both of these terms in our calculator. Let's do that. So we've got 15,191 squared minus 10,300 squared. Press equal. 1, 2, 4, 6, 7, 6, 4, 8, 1. Alright, so let's write that. What color have I not used yet? Let's try purple. So I've got 1, 2, 4, 6, 7, 6, 4, 8, 1. And that is, let's divide that up, 124 million, so a pretty big number. 124,676,481. I had a student remind me that I can use, instead of putting commas here that kind of look like decimals, you can just put little apostrophes to divide it up into groups of 3. So now you see it's 124 million about. And that's going to equal 20,600 R. Now we're going to divide both sides by 20,600. Let's do that. So here's my number already in my calculator, divided by 20,600. That equals 6052.25, so 0.3. 6052.3. So we're going to end up with, let's scroll up a little bit, 6052.3 is the approximate value of our radius. So the radius of Venus is about 6,052 kilometers. So here's our final answer. And I'll put my explanation in here. It's telling me to give an explanation of how I calculated it. Let's do that all in one answer. So here's a possible way of writing it. By using the knowledge that a radius and tangent meet at a right angle. There's some of the reasons we can actually use this method of using a right triangle. By using the knowledge that a radius and a tangent meet at a right angle. I'm gonna try to correct that. Sorry about this for a moment. Let's see if I can slide that over. Well, not pretty because I ended up messing up my line. Let's try one more time. I should have just rewritten it, but I'm being lazy. There, that worked. Meet at a right angle. I used the Pythagorean theorem to find a radius of about 6,052.3 kilometers. And that's a pretty good sentence. Again, you can write this all sorts of ways, but if it's asking you for an explanation, class, you don't want to just say the radius is 6,052.3 kilometers. In your answer, you need to explain how you calculated it. I did this because I know a radius and a tangent meet at a right angle, so then I can use Pythagorean theorem. And there is my approximate radius for the planet Venus.